Today we're going to be talking about solving equations. An equation is a math sentence showing two expressions that are equal. It has two sides that are equal. An equation has an equal sign and both sides will be equal. For example, this is your basic equation. 2 plus 7 equals 9. So it has two sides that are separated by the equal sign. This is your first side. It is your operation side. You're either adding, subtracting, multiplying, or dividing. And then you've got your equal sign, and then you've got your answer side. So you've been doing equations your whole life, just not really even calling them equations, just calling them problems or something like that. But this is typically what an equation is. Now, what changes is when we start out adding algebra to our equations. Okay, we've got the math equation 2 plus 7 equals 9. When we add algebra to it, something happens to one of the numbers. It actually sort of disappears. And it is replaced by a letter. Solving algebra equations, what you're solving for is the variable or the unknown. So when you are solving for an unknown, what you have to do is figure out what it is. Now, I know that you know the answer. I know that you can look at that and go, something plus 7 is 9. Well, it's going to be 2. The thing about algebra is that you have to sort of follow the steps and follow the pattern on how to solve equations. Mental math is great and we use it a lot, but for the beginnings of algebra, you kind of have to do it step by step by step. And what I mean is, when you have an algebra equation here, like a plus 7 equals 9, you have to use the inverse operation. Inverse means opposite. So an operation is what you are doing in the math sentence. So you're either adding, subtracting, multiplying, or dividing. So in this particular sentence, in this particular math sentence, we're adding. So the inverse operation would be subtracting. So we would subtract 7. Now, here's the kicker. When I have an algebra equation, if I subtract 7 from one side of this equal sign, I must do it from the other side of the equal sign. So what I have now is a plus 7 and a minus 7. If I have positive 7 and minus 7, if I have $7 and I spend them all, my wallet now has no money. So I'm only left with my A. I need to bring down my equal sign. 9 minus 7. Remember, we had to do it to both sides of the equal sign. So 9 minus 7 is 2. Now, everywhere that I go in this sentence, if I have an A, I should be able to replace it with a 2, and that sentence should be true. So let's try it. If A plus 7 is 9, I'm going to plug in the 2. 2 plus 7 should equal 9. And, of course, we know that it does. Now, words like equation, expression, variable, inverse operation, those are great, fantastic math vocabulary words. However, sometimes it's easier to think about math with a little trick. And so the little trick that I like to think about for math is, and especially when solving equations, is I like to think of this variable here as a grumpy old man who just wants to be left alone. Right now he's got a force being acted upon him on his side of the equation, and that force is a positive 5. I know it's a positive 5 because if it was a negative 5, it would have a negative sign in front of it. So it's a positive 5. If I have something positive and I want it to go away, for example, if I had actually $5 and I wanted to have no dollars, I'd spend it. Well, it's kind of the same thing in an algebra equation. If I have a positive 5, to make it go away, I make it a negative 5. If I do it to this side of the equation, this side of the equal sign, I must also subtract 5 from this side of the equal sign. So a positive 5 and a negative 5 cancel each other out, leaving me only with my a, which equals 11 minus 5, which is 6. Now, if this is true, and a does in fact equal 6, everywhere I see a in my original equation, I should be able to plug back in a 6, and 5 plus 6 should equal 11, and it does. And I know you knew that ahead of time. I know that you looked at that and went, 5 plus a is 11, well, that's 6. I know you knew that. But there are steps, and there is a process that you do have to follow. Okay, let's see if we can apply what we've just learned to subtraction. Now I've got the equation c minus 1 equals 8. I need to solve again for c. So I need to do the inverse operation. Well, right now, c has a minus 1. The inverse operation would be plus 1. If I do it to this side of the equal sign, I must do it to this side of the equal sign. Now I have a negative 1 and a positive 1. If I have negative $1, and I were to add 1 to it, that brings me up to 0, right? Same thing here. If I have a negative 1 and a positive 1, they become nothing. They cancel each other out. So I'm only left with my friend, the c. 8 plus 1, if I do it to this side, I do it to this side, so I have to add 1 here, becomes 9. Now, again, if I were to go back into my original equation, and everywhere I saw a c, I plug in the number 9, we'll see if it's true. Instead of c, we've got 9 minus 1 equals 8, and that is true and correct. I got it right. Let's see if we can do a couple more of these. Let's say we've got f minus 3 equals 5. And we'll use the grumpy old man scenario on this one too. So our grumpy old man is f, and he wants to be left alone. So right now on this side of the equation, he's got a negative force being impacted on him, negative 3. So how is he going to get rid of the negativity, the negative vibe? Well, he's going to add positivity to it. He's going to add a plus 3. And again, if I do it to this side of the equation, I must do it to this side of the equation. So if I add 3 here, I add 3 here. That gives me f. My negative and my positive cancel each other out. Bring my equal sign down. F equals 8. Again, if I were to go plug everywhere I see an F, if I were to plug an 8 in to that sentence, 8 minus 3 equals 5, it should be true, and it is. Still sticking with subtraction, it works even with fractions. Let's say I have the number n. I'm subtracting 1/4 from it, and I get 3/4. Again, grumpy old man wants to be left alone. So in order to eliminate myself from the negative 1/4, I add a positive 1/4. If I do it to this side of the equation, I have to do it to this side of the equation. Also, remember, when we're dealing with fractions, adding and subtracting fractions, they must have the same denominator. These, luckily, they do. So it's pretty easy. 1/4 plus 1/4, negative 1/4 plus a positive 1/4 cancel each other out, leaving me with just n. 3/4 plus 1/4, remember, we only add the numerators, we do not add the denominators. So 3 plus 1 is 4. The denominator stays the same, which is 4. N equals 4/4, or 1/2. Now let's try one without the same denominator. What will we do here? Our first instinct is probably just to add 1/3 to each side and move on our merry way. Well, we can't do that because the rules of fractions still apply, even when we're doing algebra. So what we have to do is find that common denominator between 3 and 9. And if we know our fractions really good, we know that our common denominator is going to be 9. How do I turn a 3 into a 9? Well, I multiply it by 3. If I do it to the bottom on a fraction, I must do it to the top. And so my actual equation is going to be s minus 3 ninths equals 7 ninths. Now I can actually start doing the algebra work. Again, I have to get this alone. I have to get my variable by itself. So in order to do that, I take the negative and I make it a positive 3 ninths. If I do it to this side of the equal sign, I must do it to this side of the equal sign. The negative and the positive cancel each other out, leaving me with s equals 7 plus 3 is 10. The denominator stays the same. We don't add it. We only add our numerators. And 10 over 9 is the same thing as 1 and 1/9. Here's a word problem for you. Pete is 15 years old. This is 4 years younger than his older brother, Jay. Write and solve an equation to find Jay's age. When we're dealing with the word problems and equations, what you want to do is kind of figure out what you know and what you don't know. And sometimes even what you don't know is more important than what you do know. So let's look at what we don't know first. We know that Pete is 15 years old, so that's fantastic. He's 15. Awesome. How old is Jay? We don't know. Jay is our unknown. So we're going to call him J years old. So Pete is 15 years old. So I know I'm going to have a 15 in there somewhere. J is something we don't know. But we know that Pete is 4 years younger than his older brother. So J is older. So J minus 4 years is Pete's age. How do we solve that equation? Well, again, we need to isolate the variable. It needs to be by itself. In order to make that variable alone, we add 4, because we're subtracting first in the original equation. So those would cancel each other out. So J is equal to 19. Now, would it be wrong if I said 15 plus 4 equals 19? Is that what we were actually asking now? When I say somebody is 4 years younger, am I adding or subtracting 4 years? I'm subtracting. So when somebody's 4 years younger, that tells me it's a subtraction. Again, I don't know Jay's age, so I had to give him the variable. You have to do, even though this is essentially the same thing, right? 15 plus 4 is 19. You have to do what the problem tells you to do. So again, it's very, very important that you kind of watch for keywords. If somebody's younger, we have to do a subtraction problem. And that's the long and short of that.